let's determine the intervals of concavity of this function and inflection points. How do we do this? Let's take the derivatives of the function. The first derivative is 6x cubed, not x cubed, but 6x to the power 5 minus 40x to the power 3. So if we take this into 2x cubed parentheses, what is left? 3x squared minus 20, right? Okay, so this is the first derivative. Let's look also at the second derivative. For the second derivative, we have 30x to the power 4 minus 120x squared. So if we take this into 30x squared parentheses, we have x squared minus 4. Okay, so we can write this as 30x squared, x minus 2, and x plus 2. So if you look at the second derivative, so this is equal to 0 if x equals 0, x equals 2, and x equals minus 2. So these are the possible inflection points. And let's look at the sign of the function, second derivative. So if x is greater than 2, this is positive, and this part is positive. So this is positive. And x minus 2 is a single root, so there will be a sign change here. But x equals 0 is a double root, so that the sign will not change here. And this will be a plus, which means for the second, for the function itself, this function is concave up, concave down here, and then concave up here. So the inflection points are only x equals 2. So this is an inflection point. And another inflection point is this. You see x equals 0 is another inflection point because the concavity does not change there. But at x equals minus 2 and x equals 2, the concavity changes.